How to build a model steam engine. And this is the Stuart Models Victoria Part 5, Machining the Pulley. There are plenty of large parts in this engine and quite a few small, almost insignificant parts, like this pulley. The pulley is quite an attractive part of a Stuart Victoria. It sits on the end of the crankshaft, just in front of the flywheel. The first thing to do is to clean up the casting. I removed the lump of moulding sprue with the bandsaw and then finished it off on the belt sander, and now I'm starting the machining operation. The first thing I did was take a facing cut, and this will allow the rough casting to run true when it's reversed in the chuck. And here it is the other way around, and now I'm facing the other side. I'm only taking light cuts, but I'm making sure I get under the skin of the casting. I always enjoy machining parts like this because they're not critical. The actual fit of them is fairly critical, but the shape of them isn't, so you can have a bit of artistic license. However, I am following the drawing's dimensions. I've just used the micrometer to check the size of the centre part of the flywheel, and the centre part of this pulley needs to be exactly the same diameter as the centre part of the flywheel, so I'm checking it frequently with the micrometer so I get them both the same. This centre part of the pulley needs to be much shorter than this, so I can try the micrometer several times, and if I go undersize right on the edge it doesn't matter because that part's going to be turned away. Before I take the final finishing cut all the way down the centre part of this pulley, I need to definitely make sure it's the right size. So a final check with the micrometer confirms this, and I run the lathe tool all the way down. Once I've finished turning the centre part of the pulley, I turn my attention to the outer part, and I'm taking a facing cut all the way across. Now turn my attention to sizing the centre part of the pulley to its finished dimension, which is 1/2 inch. And now the inner part of the pulley is completed. It's time to drill the hole in the centre, first of all with the centre drill as usual. This is getting to be very routine. You'll pick it up if you just keep watching it. And then I drill the hole all the way through the casting using a drill that is 1 imperial size under 7/16 of an inch. And unlike the flywheel, when I use the boring tool, just to show you how to use a boring tool, for this job I'm going to use the 7/16 of an inch reamer, because it's simpler. And my golden rule for reaming, to get the hole to be an accurate size, is a slow feed and a slow speed. Some of the fundamental principles that I quote in these videos I'm sure people disagree with, but I'm not talking about industry, full-size engineering with big machines. I'm talking about reaming a hole in a piece of cast iron in a home workshop on a very small lathe. So in what seems like no time at all, as I've been talking while I've been watching this, the ream has gone through the hole, and we now have a perfectly sized 7/16 of an inch diameter hole in the middle of the casting. And to double check this, I'll push the reamer through just one more time, and yes, it seems fine to me. Now it's time to try the crankshaft in place and see how well it doesn't fit. Oh dear, the crankshaft doesn't fit in this hole. And the reason that this crankshaft does not fit in this hole is because the crankshaft is 1/2 inch in diameter, not 7/16. For any viewers out there who just work in metric and not imperial sizes, I'll just explain. 1/2 inch is 8/16 of an inch, that's fairly logical, and 7/16 of an inch is 1/16 under 1/2 inch. And I think the plan is that you get the piece of mild steel with the casting set, and what you do is you turn it down to 7/16. But for me, this is engineering for the sake of it. I don't know why they didn't give you a piece of 7/16 steel to start with. So in this Stuart Victoria that I'm making, I am going to modify it. You don't have to do this, but please bear in mind it's very easy to get confused. You have a piece of steel that's been given to you which is 1/2 inch in diameter, so you automatically presume that you need to make the hole in the flywheel 1/2 inch in diameter. But what you're supposed to do is ream the hole in the flywheel and the hole in the pulley to 7/16 of an inch in diameter, and then machine the piece of mild steel down to 7/16 of an inch. But I don't like the idea of that, because a beginner is not going to get a very good finish on the shaft. You'll probably find the lathe tool isn't sharp enough, and maybe your lathe isn't accurate enough, so to play safe I'm going to use a 1/2 inch diameter crankshaft, which in itself is slightly stronger than a 7/16 of an inch crankshaft as it's a tiny bit thicker. I'm going to buy a piece of silver steel from Blackgates Engineering. Silver steel is more hard wearing and it's also precision ground to the exact size. And the reason I can do this is I'm going to modify the eccentric. There is plenty of tolerance on the flywheel to accept a 1/2 inch shaft, and also the pulley. No problems at all there. But the design of the eccentric is different. The design of eccentric for this engine has a machined in collar, and through this collar goes a very small grub screw to hold the eccentric to the crankshaft. And personally I've never liked this design. What I do is drill a hole in the centre of the thickest part of the eccentric, and then I thread it and I put a larger grub screw in, and I use an Allen key from the outside by drilling a hole in the bottom part of the eccentric strap so that I can adjust the eccentric on the crankshaft without any fear of stripping the thread of the very thin machined in collar on the eccentric. If you have a look at an engine like a number 10, you will see that the eccentric has this very thin collar, and usually it has a 5BA slot head grub screw. I prefer Allen head grub screws because they're more secure and you can put a little bit more pressure on them. So if you keep watching the series, you'll see how I modify this. This pulley needs to be 1 inch wide from front to back. And while I've been talking about all these eccentricities, I've been busy machining this pulley to its finished size. It is supposed to be, according to the drawing, 1 inch thick, which is fine. It's going to be 1 inch thick. I don't have a problem with that. The only modification I've made is, as I've just said, I'm making my crankshaft 1/2 an inch thick because it will be stronger than if it was 7/16 of an inch thick. But I must stress that you don't have to do this. You can go with the drawing if you wish and it will work out perfectly fine. In this clip you will notice that I've changed the position of the tool, and this will allow me just to take the sharp edges off this middle part and also the outer part. Because I don't want anyone going, "Oh, look at this pulley spinning round, isn't it lovely? Let me just touch it and cut my finger and bleed all over the baseboard." We'll have none of that. I do not like sharp edges on pieces of metal that can come into contact with fingers. And now I'm taking the very final, incredibly light cut to get a good finish. And to make the pulley look even better, I'm going to use some sandpaper. Yes, here it is, a piece of coarse sandpaper, to really clean up these inner edges, and I think you will agree it looks better for it. I'm now turning the outside diameter of the pulley, and as you can see I'm taking quite a deep cut. I'm getting right underneath the skin of the casting to remove all the shale and the sand and the mess. One viewer seemed to be very concerned when he saw me using sandpaper in the lathe that the grit of the sand from the sandpaper would cause damage to the lathe. Well, I'm sorry, I can't go with this at all. In the lathe I'm turning castings, and in the outer skin of the castings they're absolutely full of casting sand. So if anything is going to damage the lathe bearings and the bed, it's not going to be my little piece of sandpaper, it's going to be all this immense amount of sand that's flying about when I machine castings. For instance, the larger of my two lathes, the very old Smart & Brown lathe, which is probably from the 60s, and I've had it for 35 years, and I've done lots of sanding, and I've done lots of grinding, and I've done lots of cutting of castings in this lathe. The bedways are as good as on the day that I bought it, and it seems to be fine, as is my little Boxford lathe. And at the moment I'm busy going down the grades of sandpaper, and here's a quick touch with the file to make sure the edges are not sharp. And I think it's looking quite good. That's shiny enough. Now it's time to put the grooves in it. The drawing shows 3 grooves in this flywheel, and each of them are supposed to be 1/8 of an inch deep. And what I'm doing here is using the existing lathe tool that I've been using throughout all these operations to just make some marks to show me where I need to put the grooves. I measured the mark in the centre, and then I put the rest of the marks in by eye. This is a very small lathe tool that I found in a box in the workshop. So what I did was, I ground it to the shape I wanted it to be to make these grooves. It was originally a very small V tool. It's a carbide tip tool. I think I'll put this form tool in a safe place because it is going to be useful to have a tool that I can immediately fit to a holder that will make round bottom grooves. I could use a parting tool, but that would give flat bottom grooves, and the drawing definitely shows round bottom grooves to take belts for driving accessories. To finish off the grooves, I'm just using some medium sandpaper and then a final polish with some 400 grit wet to dry paper. All that's left to do now is to drill a 1/8 of an inch diameter hole through this part of the pulley. I can then tap the hole 4BA, fit a 4BA grub screw, and this will securely hold the pulley to the crankshaft. Here's a tip that you might find useful. As this pulley has been fitted in a 3-jaw chuck, there are 3 sets of lines made by the jaws of the 3-jaw chuck, and if you line up your centre drill with one of these, it will be exactly in the centre of the main hole where the crankshaft goes. And once I fit the grub screw, here's the finished thing. I'm temporarily just going to sit this on the crankshaft so you can get the idea of how well it's going to look, and to me it looks okay. So that's it for now. Thanks for watching, and I hope you found it useful.